Hey, welcome to your last video for topic 2. Today we are going to be learning about skill 5, which is creating or writing equations with variables on both sides. So what that means is on either side of your equal sign, you will have an expression that includes a variable on each side. So our strategy to writing an equation in this way is going to be to write one expression first, and then writing a different expression based on the other situation, and then setting them equal to each other. So to do that, we need to remember way back to our very first skill, which is creating an expression. So to do that, we need the formula delta times x plus f of 0, where delta stands for the change or the rate of change. And to find the change, we're going to look for the words each, every, or per. The other thing we need to find is the f of 0, and the f of 0 stands for the starting value. The x is just going to be our variable. That can stay as an x, or it can turn to a different letter. Doesn't really matter, but there does have to be a variable somewhere included in there. So, if we can find these two pieces of information, the change and the starting value, for each one of our situations and set them equal to each other, we can do skill 5, which is a level 3 skill. Example 1 looks a little bit long. Miss Brackemeyer and Mrs. Ramirez are going bowling. They could go to Pin Palace or Loopy Lanes. Pin Palace is $5 to rent shoes plus $10 each game. Loopy Lanes is only $1 to rent shoes, but is $12 each game. Write an equation to represent how many games they would have to play in order for the two bowling alleys to be equal. So, what should kind of naturally come out of a question like this is that there are two different situations. When Miss Brackemeyer and myself are going to go bowling, we have two options, right? We have the option to go to Pin Palace, or we have the option to go to Loopy Lanes. Those are naturally going to become our two expressions. So when I go to create my expression, remember that we have to find the delta and the starting value to create that expression. So if I read back through in the Pin Palace information, I'm going to underline all of that in green. Let's see, Pin Palace is $5 to rent the shoes plus $10 each game. So I see this word each, so that is going to be my trigger that's going to be the change. So that each is going to go into my equation for my delta. My x is, I'm just going to leave it as an x, or you could put a g, which would represent game. And then your starting value, the other number left over is the $5, because you have to spend $5 to rent shoes at a bowling alley. So this expression would be the expression for Pin Palace. My other option would be Loopy Lanes. Let's make the expression for Loopy Lanes, still looking for my change and my starting value. Loopy Lanes is only $1 to rent shoes, but is $12 each game. So, I do see the word each again, but that's with $12 this time, so I know that my change, or my delta, is going to be 12, and then we're going to keep the x right there since we used x in the first time, or if you wanted to use g, you could use g as well. My starting value, though, is the other number. I only have to start paying $1 for my shoes. So now that I have those two expressions, the only thing I have left to do to answer the question is to find out when will they be equal. For them to be equal, what do you need to put? You just need to have an equal sign. So take this expression, set it equal to this expression, and there is your final answer. 10x plus 5 equals 12x plus 1. Second example, just to make sure we got it, is Juan's parents are sick of him being late to school. To try and motivate him, they offer him two different allowance options. Option A, Juan can get $50 each month, but has to pay his parents $5 every time he is late to school. Option B is Juan can get $100 each month, but has to pay his parents $20 each time he is late to school. Write an equation to represent how many days Juan would be late for these options to be equal. So again, it kind of naturally falls out that there are two different options. This time they're literally called option A and option B. So I'm going to separate those. And my strategy is again to focus on option A and make an equation, and then fix my focus into option B and make the expression for each one of those options. So option A, if we focus on that, Juan can get $50 a month, but has to pay his parents $5 every time he is late to school. So that change is going with the every $5 every time he is late to school. In other words, 5x. And how much is he starting with each month? Well, he is starting with $50 each month. Now let's go back and make sure that we understand our positives and negatives here. Juan is starting with a positive $50. His parents are giving him that. But if he is late to school, he has to give his parents $5. So that means that my change is going to be a -5 because he's giving that money back to his parents. So that would be negative. Now let's focus on option B. Option B, Juan can get $100 each month but has to pay his parents $20 every time he is late to school. So my starting value is going to be a positive 100. He is starting with that $100. However, when he's late to school, he has to, every time he is late to school, he has to pay $20. So that would be my 20x in my delta, or in my change. And again, let's think about our positives and negatives. We said the 100 is positive because he has that money. But when he is late, he has to pay his parents. So he has to give up that $20. In other words, making it a negative 20x. So after I have my two expressions made for each other, the last thing I have to do is figure out when will they be equal. Now, not actually figuring out the math, but simply making an equation that shows when they would be equal. And the only thing I have to do that is put an equal sign in between those two expressions. Hopefully that is going to be okay as we practice a little bit more. Good luck, and we'll talk to you soon.